guys, welcome to Fire Neurons, and here is a new video about AI problem solving. And the main fact of the problem solving is that we should know about the state space search, right? So let us go and consider what is the state. So while considering the AI problem, whatever be the problem, we should know about the nature of the problem first, and what is the start state and the goal state. So in AI, what we are doing is we are making the computer or the machine to learn or behave like a human being. So you are making the computer to learn to solve the problems. So what are the states that has to be given to the computer, that has to be precisely explained to the computer, then only it can work as we do or as we take decisions. So decision making is not a fact that is included in the machine or not a feature for the machine as a human being. So we need to represent all the states that we encounter from the start state till we reach the goal state. That is what we are going to make the computer analyze. That is what state space search. That is the first thing that we have to indicate. So whatever be the game, so this is applied when we are solving a game or when we are playing a game. So in game playing, it is the main fact, that is state space search. What are the different set of states that we encounter, the number of states that the problem can go, that is S. Capital S is represented by this number of states that the problem can go. And there are various actions according to the problem that we had to solve. There would be precised, the rules that has been explained, how to gain the next state and what is the rules that has to be maintained till we play the game. That is your actions. So there will be all possible actions has to be explained. So accordingly we will be reaching to some state in intermediate. That state is called an intermediate state. That would be your resultant state. That is result S of A. According to the action from the previous state, which state you are arising, that is your result of S comma A. And the cost is that intermediate things that we use, that means when you want to move from one node to another to solve the problem, there may be distance, maybe the time factors that you have to encounter is the cost or the distance or the time may be the factor for playing the game. So that is represented by the primitive cost S comma A. So the tuple to explain or define the state space search is S is defined such that capital S indicates the set of states or the number of states the problem can go from your start state or your initial states to the goal state, right? And that S will be precise, that would be defined, and your goal state may also be defined in that problem. But what are the intermediate states that has to be encountered when you want to reach till your goal state? That has not been explained. So accordingly, what are the states? That is your capital S. And capital A denote what the set of actions, all possible actions that has to be encountered while you are playing the game, or that is your problem, right? How to solve that problem, that is your game. For example is your game. So what are the actions that has to be performed? That is represented by capital A. Action of S is all the actions or possible actions from the start state to the goal state. What are the actions represented by each state? And result of SA means after performing an action from a state, we reach to another state. That state would be your resultant state. And cost S comma A means according to the factors that has been needed or encountered or that should be added to solve the problem. That factor can be your distance, or it can be assigned as unity, or there may be some cost that is assigned while solving the problem. That can be assigned as a distance, or it can be time. So that is represented by the cost. That is when we are moving from one state to another, what is the distance between that nodes, or what is the time factor that has been differentiated between that nodes or different between that states is called the cost of S comma A. So this is how the state space search has been defined. S is the number of states the problem can go, and S can be your start state, your goal state, and also the intermediate state. So whatever be the problem in AI, the thing is that the main factor that we have to encounter is how to represent the problem precisely. If we don't know the problem, your friend is giving you an explanation about how to play that problem, right? He is describing it. Accordingly, you learn by practice. That is problem. We know how to move whatever be the objects that has to be moved to. Suppose you want to play tic-tac-toe, what are the factors or what are the rules that you can choose that has to be maintained. The 3x3 tile puzzle, the tiles are numbered and you have to move from, you have 3 tiles, 3x3 matrix, and you have 9 tiles in it. 8 tiles has been known, but one of the tile is missing. So each tile would be numbered, and how and all we will get the position of the tiles or the goal state would be assigned, and how to gain that, how to reach the goal state, that has to be analyzed. So if we know the problem, what are the actions, that is the how to represent the problem precisely. After which only we can make the machine easily analyze, make it decision, make a decision to solve or make a way to solve the problem. So when you represent the problem precisely, then only we can analyze it. So the tuple is S. S is the set of states or the number of states the problem can go. A is the set of all possible actions, and resultant is the, according to the action, what is the next state that we reach is the resultant state, and cost is the factors that has been used to or that has to be encountered or determined while solving the problem. For example, when you are playing a water jug problem and you want to solve the water jug problem, or 3x3 tile puzzle, or tic-tac-toe game, or a chess, here you have a time factor as can be encountered, or it cannot be. It can also be has not been included. That also comes in a chess. Okay. And the cost is the minimum cost. So whatever be the problem, when you want to solve the problem, we see that it has to be, the minimum cost has to be reached. That is then only we say that the problem solving is perfect or it is precise, right? That is a way where state space searches. And accordingly we can see, for example, let us consider a 3x3 tile puzzle. Here 3 tile puzzle. Let us say the start state is given here in this by 3x3 matrix. As I said, you have 9 tiles, in which 8 tiles would be given, and one of the tile is not numbered, and we have 8 tiles which would be numbered, and we have a goal state also, that also would be there. So from here to here, how will you reach it? For that, what are the actions that you can take is define the all possible actions. That is, you can move the tile from if you consider the start state here, you can move this tile 3 to downwards, or you can move the tile 7, numbered tile 7, to upwards. And the other factor is, other action is 5 tile can be moved to their right side, and 1 tile, numbered tile, can be moved to your left side. These are the possible actions. We cannot specify it may be extra possible action, that can be illegal actions also. So what and all possible actions that you can take, that should be defined. That is represented by capital A. So here we have 4 actions. 3 tile can be gone down, can be moved down, 7 tile can be moved up, 5 tile can be moved to your right, and 1 tile can be moved left. These are the 4 actions. All possible actions has been defined. Accordingly, after moving this tile 3 downwards, you will get what? This matrix. This is your intermediate state, or you may say that this is your resultant state by using the action down, right? Now while using the action up, you have this state. This is another intermediate state. While using the action right, you have another intermediate state. While using the action left, you have another intermediate state. These states are all states are called resultant of S comma A. Okay, I hope it is clear. And from here, so what are the intermediate states that can encounter here? From the start state, you can see there are 4 intermediate states that could be, or 4 resultant states can be generated from your start state. Alright, now from here, so according now next position when you consider the down action and the intermediate resultant state, from that what and all intermediate states that we can generate, we can see. From here the 3 tile can be moved up, but the 3 tile can be moved up, or the 4 tile can be moved left, and 2 tile can be moved right. Right, but the down action is not done. So whatever actions you have taken, the next layer or the next depth, in the next depth you have only 3 branches. From the start stage you have 4 branches, and according to the action that you have taken, that actions would be performed repeatedly in the next stage, in the next branch. So here you have already taken down, so the down actions cannot be done in this. Here you have only up action, down action, up action, right action and left action. These are the actions that you can take. Now considering this intermediate state, here you can move the down, you can move the tile 7 to downwards, 8 to right and 6 tile to left, but you have no option for up action. So whatever the actions you have taken first, that cannot be reflected in the next branch. Here also you will be having 3 branches in the next depth. Okay, and here you have you can move left side, but here the action what is has been taken is you have to remove the action, or you cannot take the action right. So here also you have 3 branches, right? And here you, as you know, you cannot move, you can move to the right, but you cannot move, you cannot take the action left. Clear? So whatever be the intermediate stage from that, and when you take the next action up, here what happens, if you have taken up, then the next layer would be what you have the option right and left and down, right? So whatever be the action, that would be repeated in the next branch or the next depth. So depth wise it moves on, branching happens. And here when you to reach the goal, so if you don't have the goal state, then you don't know where to reach, where to stop the problem. It goes on, right? So for that here you may say that it would be having a complexity, time complexity. We all define the problem, how much time it takes, right? That time complexity is defined by 3 raised to 20, approximately 3 raised to 20 is the time complexity. Here the time complexity, what it describes about in the order of branching factor b raised to d, which is d is the depth of the tree. So from this example you can say that the set of state, what are the set of states? S denotes the set of states. You have the start state, the goal state and the intermediate nodes. Intermediate states that you happen is 1, 2, 3, 4 in the first branch and the next branch, and that while taking one of the action, and what are which state you are reaching, that is your intermediate state, and from that that also happens to be your resultant state, that is result of S comma A. And if you say that the branching factor is here, and from here to start state to your intermediate is unity, then all the distance would be, or the edges would be having the cost of 1. So according to the problem, there can be the cost can be defined as a unity, or you may say that it would be distance, or it may be the time factor for solving that problem. So that is the 3 by 3 tile puzzle. Hope you are clear with what is state space search. right? Only based upon this fact only we are including when we are creating or we are solving your problem. That solving a problem means if you don't know any information about the what is the problem and all, it is uninformed search or the blind search. You don't know, you just start from the start state, and when how to reach that, what are the intermediate, you don't know what is the rule that has been happening, or the possible stage, that is how many stages would be there, that you cannot specify. How much time you take, that is not given, that is uninformed. And informed means there is some idea that for this much, you may be taking this much time, or this much cost, or this much distance would be there from one state to another state, or from start state to the goal state. Then that is called the heuristic search. That is, you are adding some intelligence to the search. That is heuristic search, so that you can solve the problem quickly, analyze your problem quickly. That is informed search. So you have according to the state space search only, you can solve the, or initiate or start your problem solving. And that problem solving is in, or the searching would be in two types, that is uninformed search and informed search. Okay? So this is a 3x3 tile puzzle. The time complexity, as I said, is in order of b raised to d, where b is the branching factor and d is the depth. Okay, accordingly we can see what are the two types of search: uninformed, or which is also known as traditional search, or it can be brute force search, it can be blind search. These are named as uninformed search. That is, searching is done without any information given. You are starting from the start state, but you don't know what is the intermediate stage in it. So knowledge about the problem is less. That is what search without information. So non-knowledge is there. And the other search is informed search or heuristic search. As I said, from the start stage you have some information is added to the node, so that you can gain the next state. That is search with information. Accordingly, if you have that decision can be taken easily. That is heuristic search, or it is named as informed search. So uninformed search is search without information, and heuristic search is search with information. And traditional search or uninformed search is having less knowledge. Here informed search or heuristic search use knowledge to find the steps for the solution. What are the steps that is required to solve, which direction I should take, what are the precautions or rules that has to be followed. Some of the informations will be there in heuristic search. And uninformed search, as we don't know what are the intermediate stages and how much according to the previous problem or previous game, the 3x3 tile problem, we don't know how much branching would be there. As the number of tiles increases, the branching also increases. So as per 3x3 tile puzzles, it can be approximately, the time consuming would be 3 raised to 20, which memory cannot afford, when a computer cannot take decisions accordingly. So it is time consuming. Here informed search, since we have some intelligence added to the search, we have less time consuming. And here in this case, in uninformed search, the complexity is more. That is, whether it is the time complexity or space complexity, as memory is required. As we said, 3 raised to 20 is a time complexity, and the space also is 3 raised to 20, and it takes more. Intermediate states has to be added, different intermediate states, possible states has to be considered. So it is more complexity in time as well as space, but it is less complexity in heuristic search. Two of the uninformed search is DFS, or depth first search, and breadth first search. That is searching as the tile puzzle. That is, searching is done depth wise, right? That is depth wise, it is branching out depth wise. And breadth first search is going by level basis, right? That we will see in the next video. And here the exponential time in uninformed time is an exponential. That is what I said in the tile puzzle. It is 3 raised to 20, so it is an exponential time description, which is an NP problem, right, in AI. And we have an optimal solution can be reached in uninformed search. In informed search, as I said, it is time consuming and less complexity, less time consuming, less time complexity. So time and space complexity is less. And the few informed heuristic search comes under is heuristic DFS and A star, AO star, best first search, hill climbing are the few heuristic search. That will see with the heuristic search video. And optimality of the solution is low. We cannot say that whatever the solution that we have reached is optimal solution, is your optimal solution. So this is the difference between, or the comparison between the uninformed and informed search. An uninformed search, searching without information, there is no knowledge is added to it, and it has its time complexity and space complexity is more. It is having an exponential time complexity, wherein in the case of but an optimal solution is reached. In the case of informed search or heuristic search, search with information, that is some information or heuristic decisions or values are added into the search, so that the solving the problem is makes the information makes it easy, is better than the uninformed search. And so the less time complexity, and then optimal solution is very low as compared to uninformed search. That is, whatever solution we are reaching, that may not be an optimal solution, right? So considering the uninformed search, as I said, it can be called as blind search, brute force search, or you may say that traditional search. I would be discussing about the breadth first search, which is a level wise search, and depth first search is a depth wise search, and uniform cost search. Uniformly the cost search has been uniform bi-direction from both direction, that is from start state. We can search start from a state from the start state as well as from the goal state. Simultaneously you can take searching can be adapted, that is bi-directional search. And iterative deepening is that deepening throughout the branching depth wise is iterative deepening. That we'll discuss in the next video about uninformed search. So these are the main uninformed search that we have to see to over. And the next is informed search or heuristic search, where you are adding intelligence to the solve the problem. And the main heuristic search algorithms are hill climbing algorithm and best first search. You are finding the local optimal, right? It may be that is why we say that it is not it doesn't give an optimal solution like an uninformed search. Then beam search algorithm is there, A star algorithm and AO star algorithm. These are the main algorithm heuristic search algorithms that I would like to discuss about. And let's see in the next video about all these uninformed as well as informed search. Okay, I hope you take space, and if you have any comments, please do comment the video. How should I improve? You can give any suggestions to my video so that I can improve my video and my sessions. Okay, thank you for being with me, and see you in the next video.